The truth about CERN. For years, CERN has lived in two different worlds. In one, it is a research laboratory near Geneva. In the other, it is a machine from internet mythology, accused of opening portals, making black holes, or somehow breaking reality itself. That second version is louder. But the real story is stranger in a better way, because CERN is not trying to break reality. It is trying to understand what reality is made of. CERN is the European Laboratory for Particle Physics. It is not one device, and it is not one experiment. It is a research campus, an accelerator complex, and a place where thousands of scientists try to study matter at its smallest useful scale. The most famous machine there is the Large Hadron Collider. It is a circular accelerator built in a tunnel about 27 kilometers around, crossing the border area between Switzerland and France. The LHC does not work by smashing objects in the ordinary sense. It steers two beams of protons in opposite directions through separate pipes, inside an ultra-high vacuum, using thousands of superconducting magnets. Those magnets are kept colder than outer space. Radio frequency cavities give the beams energy. Other magnets focus them. And at selected points around the ring, the beams cross. That crossing is the moment people imagine as dangerous. But what the machine is really doing is concentrating a tiny amount of energy into an extremely small space so physicists can study what comes out. The collisions happen inside detectors like ATLAS and CMS. These are not cameras in the normal sense. They are enormous layered instruments built to catch the traces of particles that exist for fractions of a moment. A collision can produce a spray of signals. The detector records the tracks, energies, and directions. Computers then reconstruct the event, turning something invisible into data that scientists can test. That is how CERN helped confirm the Higgs boson in 2012. Not by seeing a glowing particle float through a tunnel, but by finding patterns in enormous numbers of collisions that matched what the theory predicted. This is also why the fear stories spread so easily. The machine is huge. The language is unfamiliar. Words like antimatter, dark matter, and black holes sound as if they belong to science fiction, even when scientists are using them carefully. CERN has addressed the black hole fear directly. The collisions at the LHC are high energy for particle physics, but tiny on the scale of everyday life. Cosmic rays create more energetic collisions in Earth's atmosphere all the time. And if microscopic black holes could be produced under speculative theories, CERN says they would disintegrate immediately. The important point is not that the machine is supernatural. It is that nature is already doing more extreme things above our heads. So what are scientists looking for? They are looking for evidence, rare particle decays, signs of unknown physics, better measurements of known particles, and clues about why the universe has the structure it does. The LHC is not a portal machine. It is a question machine. It asks what matter is, how forces behave, and where the current theory of physics stops being enough. That is why the LHC is being upgraded. During Long Shutdown 3, CERN is preparing the High Luminosity LHC, a version designed to produce more useful collision data and sharpen the experiment's ability to see rare events. More collisions do not mean a more dangerous machine in the Internet sense. They mean more chances to find the statistical needle inside a universe-sized haystack. The mystery around CERN is real, but it is not the mystery people usually imagine. It is not whether a laboratory is about to break reality. It is whether reality is deeper, stranger, and more elegant than we have learned to describe. CERN is not trying to open a portal. It is not trying to end the world. It is trying to understand what the world is made of.